which is coming from the tank, the top side, then tanks can be again the ruler of the war. Because traditionally tanks are protected from the frontal arc, considering that it is fighting with the land systems. But, and also to balance the weight, it is the top and rear side is generally protected with lighter armor solutions. Now these drones and other things, they are taking advantage of this lighter, the protected areas and being attacked at the top level. So we have to add protection on the top equally, which is there on the front side, and also adding the survivability. Earlier the protection means only armor, but now we have to have a layered defense system. It is not only just adding the armor materials on the tank, we have to have a system of multiple layers like camouflage, hiding it. Then we have an active protection system which will counter the incoming threats, and before hitting the tanks we can have a counter systems. So that is called active armor. Then we have a reactive armor, then followed by the last line is the passive armor. So we need to approach the layered defense mechanism. Then situational awareness. So there is a system mounted on the tank which will be surviving the situation, then alerting the RCWS and what is the coming threat is coming from which direction, and accordingly we have to plan it. Then EM suit, because nowadays the tanks, even for the vehicles also, we are seeing that a lot of electronic systems are there. So we need to ensure that they are not being hijacked or jammed. Then it will become like a sitting duck. So all these three parameters we have to add in the future AFE designs. So in DMRL, we are working on this is the glimpse of R&D activities at DMRL. We work on different battle systems. Like the first one is Indian Light Tank, then FICV, then the MBT Arjun, then Wheel Armor Platform, then Namika, then Mi-17 helicopters. So these are the main platforms. We are addressing the protection with considering all these threats, and we work on different materials, steels, ceramics, and composites. So I will not talk much about these materials because my speakers are already explained about the materials. And we use the ecosystem of academics, industry, and R&D, because academics, we use them for exploratory studies, and also the new concept for understanding. Then industries we use for prototype developments, and we work with different labs because they are system developers. So we work with the system labs to make the systems which are as per the requirements. So this is the metallic materials, because this part was not covered. So we have different steels ranging from RHA to DMR 1700. We can see the one properties I have shown here. As you increase the hardness, it will improve the ballistic performance, and now we are working on ultra high hardness steels, because as we increase the strength and hardness, it will improve the ballistic performance. Therefore, we can use the thinner materials. Therefore, we can reduce the weight of the system, and we can increase the mobility and firepower. So these are the properties of different materials. So here you can see that how the ballistic performance changes by increasing the hardness. So the last one, you can see that 1700 is, when compared to the RHA, it is 1.4 mass efficiency. That means the equal thickness, we can have 40% higher mass efficiency for the given thickness for this particular projectile. So like that, we work on improving the materials by varying the alloy combination as well as varying the process conditions like heat treatment and all. So by modifying these materials, we can increase its performance. And not only this one, after developing the alloy, the other step is called process engineering, because this material, to convert them into a useful product, we have to establish the welding procedure, machinability, and welding details, which are done at industry level. Therefore, this material can be used for manufacturing the particular systems. So we have given TO to the industry partners for all these materials. Now they are produced at industrial scale. And the ceramic materials, as we have already seen the previous speakers, how they are very effective making that lightweight armor systems. So I will not cover this one. Then ceramics, there are different materials. We are working with various industries. So there is a ceramic room in DMRL. We work on the basic level R&D. Then at industrial level, we work with the industries who are having the capability to produce different grades of ceramics as per the requirements. And so we use different materials depending on the requirement. And this is the one, this is how we achieve the multi-hit capability, which was discussed in the previous things. Because the armor performance is the combination of materials and geometry. So if you can amplify the defeat mechanisms, then you can improve the performance. So this is how, by shaping the ceramics, we can get the best multi-hit protection with a very close intershot distance. You can see here, the distance is much smaller, hardly 40 to 50 millimeter from one shot to other shot. And these are all things we have done as per the international NATO standard, that is TENAC 4569, which is considered as the stringent test method for qualifying the armor systems. And then to make it more lighter, the conventional system is we use the heavier, the monolithic structure, but now it has been changed to the using the very thin monoco vehicle structure. Then over that you will have a add-on armor concept. So in this advantage is the add-on armor are modular. If based on the requirement and operational things, these modules can be removed and again attached on demand. So therefore the system can be airlifted and it can be amphibious. So all these features we can add to the tank, and it will also add that rapid and quick deployment. And also we will have a adaptive technology, means the one armor plate will have a multifunctional. It will have a camouflaging properties as well as the ballistic protection. So these are areas we are working. And this is how the add-on armor concept. We will have one structure which is minimum metallic metal, which is the fixed structure, and over that we will use all these add-on armor concepts, which will give much advantage, like the threat level can be upgraded or downgraded depending on the battle requirement and the vehicle is deployed for particular mission. So therefore, the maintenance and sustainability will be easy. We will have a common platforms, but variety of variants. So we can modify the same platform for different missions. So the inventory will be minimized, and we'll have the optionals will be more. But the only challenge is we have to make this add-on armor as per the requirements. It will have amphibious, and it will also protect that all the multi-hit protection. Because traditionally they used to be used the thick metallic materials as a single sheet. So the multi-hit was not an issue. But when you go for the ceramic and composites, because they're all made from the brittle materials and composite layered, so we need to take it challenge and address properly to get the equal ballistic protection as the monolithic steel plates, yet maintaining the weight benefit. So these are the different DMRL technologies which are compared with the imported materials. We have a steels that are Spades 500, 650, then Jackal, then we have a K1 composite which is equivalent to a Russian textile, and Kanchan armor we all know that it is the equal to the Chobham armor, then DMR 1700 which is equivalent to the imported armor grade steels like Armax and Ramar. And in addition to that, all these ceramic materials we are working with industries. We have tuned the properties and shape of them to match with the as per the requirements, and to get the international to qualify as per the international test standards. And so these are the different products we are working. So the products which are developed at DMRL, armor for various systems, and currently we are working for armor for FICV, which we can see in the last the corner. So that is Feature Infantry Combat Vehicles, then armor for FRCV, because currently the main battle, the armors are protected about 500 to 550 millimeter penetrated FSA PDS. But the requirement is there in the internationally, they are up to 600 and 800 millimeter penetration. So we are working towards that. Then APS systems we are working. Then the light tank, which is there on the demand. So there we are working for providing the protection as per the NATO standards. So it will cover 25 millimeter and 30 millimeter FSA PDS rounds. So these are the areas we are currently working, the latest areas. Thank you. I think I have taken 10 minutes time.
Yeah, you were in time basically.
Yeah.
Thank you, Dr. Subbareddy.
Thank you.
So with that, we come to the end of the session. Any questions, please? So then I'll sum up the session then. So we heard both from CME as well as DRDO, and Colonel Kaushik then covered the different manufacturing methodologies for the personal armor, and DRDO they covered the different materials and the manufacturing technologies for them. So basically we have two perspectives. CME initiatives are basically, they are more practical, field oriented about the experience they have gained. But what I feel is more collaboration is needed now. The collaboration between CME, DRDO, academia and industry, because I could see some duplication of efforts also here. 2 or 3 type of BPJs are in parallel they are going on, mine boots also. So we should avoid those duplication maybe, and the collaboration will ensure that innovation will move swiftly from maybe a concept to a reality, and it can be delivered to our armed forces. So I thank everybody, the speakers, for their valuable contribution here, and audience also for the patient listening. I would like to express my sincere gratitude to CAPS for giving me an opportunity to be a part of this seminar. Thank you. Jai Hind.
Thank you, Chair and panelists, for such an interactive and engaging session for all of us. I would now like to invite AVM Anil Gulani, Director General CAPS, to give token of appreciation. Oh, we have Major General Ravi Arora here. Shri Vivek Agarwal. Mr. P.R. Reddy. Dr. A.S. Parihar. Last but not the least, Colonel Jitendra Kaushik. So we'll have a group photograph. With this, we come to end of session 4, and we will now move into the closing session.